All right, this is 1, 1. So number 1 says to sketch a line with point -1, 2, and 2/3. If I had a coordinate grid, you could bring it in. If not, you could just kind of eyeball it for now. That's fine. -1, 2 would be here. And then my slope is 2/3. So I can go up 1, 2, and to the right 1, 2, 3. Or I can go down 2 and to the left 3. Either way, you should get your line. These are lines, so put arrows on them, okay? The things that you plotted for your quiz may not have been full lines or full graphs, so you could leave those arrows off. But now we know these are lines, so that lines continue on forever in both directions. So they have arrows on them. Number 2 says find the slope and y-intercept of 5x minus 3 equals y. This is already in slope-intercept form. It's just the y's on the right side. This 5 is your m. And b, or y-intercept. So the b is -3, but the y-intercept is 0, -3. Keep that in mind that we put intercepts in coordinate point form, which I think a couple people made that mistake on your quiz. I tried to catch it. I will release the feedback. I'm finally freaking done with those things. That was fun. But I'll release the feedback on those today. Number 3, find the slope given point. So this is one of the equations that we used, y2 minus y1, or formulas, over x2 minus x1. And we plug it in, so it's -12 minus 6, and 7 minus a -5 becomes 7 plus 5. -18 over 12, which is -9. Oops, 3 goes into both of those. Nope. 6 goes into both of those. -3, 2. Questions on that one? Okay, number 4, find the equation with m equal to -2 passing through point 2, -3. Remember, I prefer point slope, but it doesn't mean you have to. I will work it out this way. You can also use y equals mx plus b. Y minus a -3 becomes +3 equals -2 x minus 2. Distribute the -2. Y plus 3 equals -2x plus 4. Subtract the 3, y equals -2x plus 1. Number 5, find the equation of a line that passes through 3, 4, and -2, 5. So the first thing we have to do is find the slope. 5 minus 4 over -2 minus 3 is 1 over -5. Then I can pick either point. So I'm going to pick the first one because there's no negatives there, and that's when stupid mistakes get made. And plug it into point slope. Y minus 4 equals -1/5 x minus 3. Then I'm going to distribute my -1/5. Y minus 4 equals -1/5 x plus 3/5. Add the 4. Y equals -1/5 x. This has to get the same denominator. So it becomes 20/5. 3/5 plus 20/5 is 23/5. So you can leave it like that for your answer for the equation. Obviously, if I was to graph this, I'd have to convert that 23 over 5 into 4 3/5. All right, number 6, find the slope of a line that is A parallel and B perpendicular to the equation from 5. So here's my equation. Well, there's my slope. There's my equation and there's my slope. The slope of a line parallel to it is going to be the same, which is -1/5. The slope of a line perpendicular to it, remember we change the sign and flip it, which would be +5. Questions on any of the warm-up? All right, so remember I said yesterday that webinar after the due time, which was 8 a.m. this morning, you can go back in and check your answers. Okay, and then if you have a question that you still don't understand, obviously feel free to ask. I don't know if we'll get time to do it today in class, but those are questions that I can answer in class, or I can add to the video if you need them that way too. You just need to let me know, which means you have to communicate with me. okay? In a regular class setting, I'd be like, okay, check your homework. All right, which questions do you have from WebAssign? Usually by the time you guys come into class, you know what you didn't know because it marks it correct or incorrect. You try to figure it out and you're like, dude, I could not figure out number 8, and I will go over number 8, okay? One of the questions that popped up a lot was the graphing utility question, which I didn't get to. Remember, I said I was going to get back to it, and I didn't. So if you had to skip that question, don't stress about it. I will go over it, okay? Hopefully at the end of today, but if not, for sure next week, we will dive into the graphing calculator, okay? So if you had to skip that question, I'm not going to take points away from you, okay? If you already know how to use your graphing calculator, then fantastic. But if you haven't learned yet, don't stress. All right, 1, 2 is called functions. So some of this is just identifying if something is a function, okay? And then some of it is function notation, which is huge on standardized tests. So a function by definition is a rule that assigns to each element x in a set A exactly one element y, which means that the x cannot repeat with a different y. When you're looking at points, it's going to give you a couple of different kinds of questions. It'll ask you, if given this set of points, is this a function? And if the x repeats with a different y, it is a no. If you're given an equation, then you have to think about how would an x repeat with a different y? What kind of equations would those be? And those would be ones in which y would be raised to an even power or an absolute value. So if I saw x equals y to the 4th, that is not a function. If I had x equals absolute value of y, that is not a function. X can be squared and x can be an absolute value, but y cannot. So if I'm looking at the coordinate points, I don't have to look at the y's at all, actually, until I see an x that repeats. So if there's all different x's, my answer is yes, I don't even have to look at the y's. But if I have an x that repeats, I have to look at the y's. If they also repeat, it's fine. It's just the same point repeated. But if the x repeats with a different y, my answer is no. Those questions will look like this, right? So example 1 says, determine if the relation is a function. So all I have to do is look at the x values. Do any of those x values repeat for A? No, which means this is a yes, and I don't even have to look at the y's. The y's can repeat, the x's can't repeat with a different y. Look at B. 2, 3, 2. Now my x repeats. If the x repeats, now I have to compare the y's of those x's. If they are the same, it's still a yes, but in this case, I can't have 2 with a 5 and then 2 with a 6. This is a no. It's not a function. So the x can't repeat with a different y. Then, based on equations, we said, right, it's a no if, sorry, my iPad fell. A no if y is in raised to an even power or y is an absolute value. So if you look at C, are either of those cases happening? No, which means this is a yes. How about D? Is y raised to an even power or an absolute value? Yes. Good, thank you, Amanda. So this is a no. And E, is y raised to an even power or an absolute value? Yes, so this is also a no. So far, just based on the points in the equation, we're going to get into based on the graph in a minute. Questions on those?
Miss Chris Weiser does. Thank you.
You're welcome. All right, so evaluating a function, and again, like I said, this is heavy standardized test stuff. Like you'll see something like f of 2. And that means that whatever the variable that's normally in there, which is usually x, I take and replace it with 2. That's all. Plug it in, simplify it, okay? Obviously, these get a little bit more complicated, but it starts out as basic as that. And those examples look like this. Evaluate the function at the indicated value if f of x equals x squared minus 1. So for A, if f of x we're saying the x is now -3, all I have to do is take the -3 and plug it in the place of the x. So -3 squared minus 1, 9 minus 1 is 8. So f of -3 equals 8. Then I go to b. Now it's f of 2. So I take the 2 and I plug it into the x squared. 2 squared minus 1 is 4 minus 1, which is 3. So f of 2 equals 3. And c. Now I have an expression in here, but this whole thing still gets plugged in the place of x. So this becomes a plus 2 squared minus 1. And then, common mistake, even like grown adults do this and distribute this. Remember, we can't do that. You can't, that's not a squared plus 4. This has to be a plus 2 times a plus 2 minus 1. So FOIL it, a squared plus 2a plus 2a plus 4 minus the 1. A squared plus 4a plus 3. So that's f of a plus 2. Questions on those? All right, piecewise defined function. So a piecewise defined function means that the function changes based on the different values for x. So it will say for x being in this range, if x is less than 1, then use f of x equals this. If x is bigger than 1, then use f of x equals this. So they're different parts depending on the actual value you're plugging in. Eventually, we're going to learn how to graph these. Right now, we're just evaluating them. So they look like this. It says evaluate the piecewise defined function at the indicated values. So notice that I have two different options for f of x. It's saying f of x is x squared if the value I'm plugging in is less than 0. And f of x is x squared plus 2 if the value I'm plugging in is greater than or equal to 0. So the first thing we're going to do is figure out, is the number I'm plugging in part of the less than 0 or the greater than or equal to 0, and then from there plug it in. So if I look at f of -2, is -2 less than 0 or is it greater than or equal to 0?
Less.
Less than, which means I'm going to take this equation, which is just square it. So -2 squared is 4. F of -2 is 4. Is 0 less than 0 or greater than or equal to 0?
Equal.
Equal, which means I'm going to take this one. 0 squared plus 2, 0 plus 2, which is 2. So f of 0 equals 2. And the last one, f of 3. Is 3 less than 0 or greater than or equal to 0?
Greater.
Good. So I grab the second one. 3 squared plus 2, 9 plus 2, which is 11. Questions so far? Actually, I'll check, but I'm almost 100% sure it says this, and then it gives you the blank. And you just have to fill in the number. Yeah, I'm almost 100% sure, but I'll look at that. Good question, though. It's what's happening. All right, so now this one says, find the values of the function such that f of x equals 0. So all we have to do is literally replace f of x with 0 and then solve the equation, okay? So for A, we're saying where would f of x equal 0, which means make f of x equal 0, and I get 0 equals 14 minus 2x. Then solve your equation. So I can add the 2x to the other side, then divide by 2, and I get x equals 7. Easy stuff. So if I plug that in, I should get 0. These you can all check. Plug them back in, make sure you get 0. B, just in case you missed it, factoring is back. This is one of those things that will never go away as long as you take math classes. If factoring is where you feel like the least confident, then if you go to iTunes U and you go to the 1.2 section, there's a video there that goes through all the different types of factoring. I'm not going to teach you how to factor, okay? So you've got to make sure that if this is one of those skills you need to review, that's where you find that content, okay? So hopefully we know that if I set this equal to 0, and it's a trinomial with nothing on the front of the x squared, that I'm looking for the factors of the last term, negative 14, that add to negative 5. And what are those factors?
X minus 7 and x plus 2.
Perfect. Set it equal to 0, and I get positive 7, negative 2. And I believe that WebAssign will tell you like which order to put that in, smallest x first, and you'll know to put that in that order. But these are both your answers. So those negative 2 and 7 would both be the answers. Or x equals.
Chris, why is there, because you put the 0 in the end, why don't you just plug in the x, the zeros too?
Because the 0 is not here. It's not f of 0. It's saying what are the values such that f of x equals 0. So this whole thing is 0. It's different from the last one. If you're plugging in, it looks like that. Does that make sense?
Yeah.
Okay. All right, last one. Same thing. F of x becomes 0. So 0 equals x to the third minus 2x squared minus 2x plus 4 over 5. How do I solve that? What's the first thing you would probably do? Hopefully. How do I get
rid of the 5?
Good, Sai. How do I get rid of the 5?
Multiply the 0, I guess, on the
Yep.
left side? Or
Multiply 5 on both sides. It cancels out, right? Because 0 is times anything is 0. Now I have 4 terms. So, all right, we're going to factor by grouping this. From the first set of parentheses, the greatest common factor is x squared, and it's x minus 2. Second set of parentheses, if I take out a 2, opposite signs, I need the signs to match. So I take out a negative 2. And then the greatest common factor is the x minus 2. And the x squared and the minus 2 get grouped together. Oops, yeah. So now if either of those equals 0, the whole thing equals 0, which means this is the point I can split and solve it. Add the 2 here, and I get x equals 2. Add the 2 here, and I get x squared equals 2. Square root both sides, making sure I do that plus and minus, and I get x equals plus and minus square root 2. So there are 3 answers here. X can equal negative root 2, positive root 2, or 2. All of those would give my function a value of 0. And again, these you can all plug in and check, because if I plug that in, I should get 0 for each of those. Questions on that one? So again, a reminder, if factoring is what gets you, there's a review video on the iTunes U course under 1.2, because that's where we're at, of all the different types of factoring. All right, equivalent functions. The word equivalent means equal, right? So if it says at what values would these be equivalent functions, you simply set the functions equal to each other and solve for the variable. Easy stuff. All right, example 5 says exactly that. Find the values of x for which f of x equals g of x. So my f of x is here, my g of x is here. If I want to see what values would make them equal, I just say x squared equals 2x plus 8. And then as soon as you see an x squared and an x, hopefully the factor part of your brain turns on and says get everything to one side. I prefer to keep the x squareds positive, so I'm going to move the other stuff. So it's x squared minus 2x minus 8 equals 0. And then I got to factor this. So put it in parentheses, nothing in front of the x squared, which means these are x's. factors of -8 that sum to -2, -4, +2, split and solve. X equals 4 and X equals -2. All right, the last thing we're going to talk about today, and then I'm going to jump to the graphing calculator. We're not going to do the very last concept in this today. It's called domain. So domain, which hopefully, again, we have heard of before. Domain is all the values all the values you can plug into X. And the domain of a function is all real numbers except if one of these three cases happen. If there's a variable in the denominator, if there's a variable under a square root, or the combination, if there's a variable under the square root in the denominator. If none of those three things happen, the answer is all real numbers. If one of those three things happen, then you follow what it is. If there's a variable in the denominator, then we say the denominator cannot equal 0. And those are the values that X cannot equal because it would be undefined. If there's a variable under a square root, then we say whatever's underneath the square root has to be greater than or equal to 0 because we can't square root a negative number. And then if that square root is in the denominator, now we say it's got to be greater than 0. It can no longer equal 0 because it's in the denominator, and if it equals 0 in the denominator, it is undefined. All right, so here's some domain examples. So it just says find the domain of the functions. Remember that it's all real numbers except variable in the denominator, variable under a root, variable under a root in the denominator. So when I look at A, are one of those three cases happening? Yes, right? There's a variable in the denominator. Yes? So I don't worry about the top because the top can be 0. 0 divided by anything is 0. That's fine. The problem comes with the denominator. So this here is what I have to figure out how to restrict. So they then say this cannot equal 0 and I get X cannot equal -1. Now in just normal regular notation, it's X cannot equal -1. You could also write it as all real numbers except -1. And then you get interval notation. And that is, what are the numbers that it can be? -infinity up to -1, not including -1, so it gets a parentheses, union -1 to positive infinity. Which means all the numbers except for -1. The parenthesis says I can't include that. It can include all the numbers up to -1, but not -1, and then all the numbers after -1. So this, if you were in Algebra 2 honors, you should have definitely seen interval notation. If you were in regular, you may not have. So we'll practice it a little bit more, but that's interval notation. That's how I would say all the numbers except -1. Now go to B. Now I have the square root case, right? So the square root case says if it's in the root, whatever that is has to be greater than or equal to 0 because I can't square root a negative number. So I would get X is greater than or equal to -3. In words, all numbers greater than or equal to -3, because -3 is part of it. In interval notation, it starts at -3, but it can include -3, which means it gets a bracket. And it goes, all of the numbers bigger than it, which go to positive infinity, close the bracket.
So for number 1, or for A, should there also be brackets somewhere?
No, because it's not or equal to.
Oh, right. It doesn't include the negative
Exactly.
Okay.
If it was or equal to, it gets the bracket, but that it can't include it, so it gets a parentheses. Good question, though.
Right. All right. Thank you.
You're welcome. Okay, so now go to C. Now I've got the square root in the denominator, which means it can't equal 0. It's got to be greater than 0. So x has to be greater than -4. Okay, all real numbers greater than 4, greater than -4. And in interval notation, it doesn't include -4, but it's bigger than -4. So I get a parentheses at -4, and I go to positive infinity. And then the last one, which is D, says I've got a square root in the top I have to worry about, and a square root in the bottom I have to worry about. So in the top, I would say this has to be greater than or equal to 0, and x has to be greater than or equal to -4. In the bottom, I have to say this has to be greater than 0. 2x would have to be greater than -1, and x would have to be greater than -1. Half. Now these are the same x's, so I can't use one without the other. I have to include both of these. So if a number line helps, draw it out. The top one tells me it's greater than or equal to -4, which means I go from -4 to positive infinity. The bottom one says greater than -1/2, which means parentheses at -1/2, pointing to the right. It's only where these overlap that I get to keep, which means it has to be greater than -1/2, and in interval notation, it's -1/2 to positive infinity. So this is how WebAssign's going to ask for the answer, in interval notation, okay? It literally says in the direction, using interval notation. And Maria, I checked, it does say f of x equals blank, and you just have to put the answer there. So the way we thought, okay? So let me just review a couple interval notation rules, okay? If something is, if it says x is greater than a number, like 2, then I go 2 parentheses to infinity, greater than. Greater than or equal to that number, and it's a bracket because it can include it. It's like a solid dot, open dot scenario, if you remember those. If it's less than a number, now the smallest number it can be is negative infinity, up to 2, parentheses on the 2. Less than or equal to negative infinity, 2, bracket 2. If it's in between two numbers, like it's got to be greater than -2 but less than or equal to 3, the left one gets a parentheses because it's greater or less than, not less than or equal to, -2. The right one gets a bracket because it's greater than or equal to, and I put a comma between them. So this is all the numbers from -2 to +3. And if it's separated out, like x has to be less than -2, or it can be greater than or equal to 3, then this gets a parentheses, union, bracket on the 3, positive infinity. So the or separates it into two parts, right? So that's like your or can't equal, like A is an x can't equal -1. So if it can't equal something, then it's negative infinity up to that number, union that number to positive infinity. But parentheses on both because it can't include that. So again, if you were in Algebra 2 Honors, you definitely got exposed to interval notation because you use a pre-calc book, but Algebra 2 Regular tends to not. Like, it's pre-calc when we start to switch it, when we start to look at college algebra in a different way, and that's when they start to use interval notation. All right, one last thing. So we're not going to do difference quotient today. That's the last part of this section. We're not going to do that today. What I want to do is do the graphing calculator with you. which I actually think I have to, hang on. Yeah, hang on. I have to stop sharing and reshare and talk to myself the entire time I do this. I don't know. All right, now you see my calculator, right? Let me delete this. Okay, so one of the questions from last night's homework said to graph something and then figure out what's the best window on it, right? So it said to graph, let me get the one that I grabbed one specifically. Where'd you go? The one I grabbed is y equals negative 8x plus 6, but they're all something similar to that. So I go to y equals, right? Oh, I got to get my mode back to function. Okay, I go to y equals, and I type in negative 8x plus 6. Two things there. The negative, if you're using your calculator for the first time, the negative has to come from the negative button, that guy, not the minus button. And the x, you can use this little variable button, x, t, theta, okay? Once I enter that in, I hit graph, and it's going to give me the graph of my line. There it is, okay? My window right now, which is usually the default, is set to negative 10 to positive 10 for both the x's and the y's. But what this question said was to change that. So for the first box, it said change it from like negative 5 to positive 5 with a scale of 1, that stayed the same, and negative 10 to positive 10, and with a scale of 1, that still stays the same. Now notice that the intervals on my x and y axis changed. X spread out more, and y was the same. Then it said do the same thing, change it again, this time negative 5 to negative 80, positive 80, that's what this one said, with a y scale of 20. Totally changes the shape of my line because my scale is so far off. And then the last one was window, negative 5, 13, scale of 1, negative 18, 12, scale of 1, graph. I didn't even catch the whole thing. So when it asks like which gave you the best graph, it probably was the answer was the third one because it gave me the most up close that caught the x-intercept, the y-intercept, right? Like that kind of thing. To me, your default is your safest bet. Negative 10 to positive 10, scale of 1, negative 10 to positive 10, scale of 1. Because that's going to be your square image, okay? You need to learn how to adjust your zoom on this because sometimes we're going to have to zoom in and out, okay? We don't have to do that just yet, but you will have to do that. So get comfortable with your graphing calculator if you've never used it before, okay? Mess around with the window, see what happens to your graphs. But if you had to skip that question, I don't want you to stress out, okay?
Mr. Supervisor?
Yes.
So what would be the reasons why it's the best? Because I put it it shows the x and y intercept and I got the one wrong. So is there any other reasons?
It shows the x and y, and I think it gives a relatively square window. You'd have checked those three.
Okay, relatively square.
Yeah.
I just didn't understand what it meant by that.
It just means that like it's for a square would be the same intervals.
Okay.
That's what it is. So like your scale is the same. The 1 to 20 would be a disaster, right? The 5 to 5 and 10 to 10, it's not the same square image, if that makes sense. That's the only time you're going to be asked something like that. You'll never be asked something like that on a quiz or a test. It's just part of the question. I wanted you to mess with the window, and I can't take off that part of the question. So I wouldn't stress too much about that.